up here, I got two line segments coming out. What are they called? I have two line segments right there. What are they called? Here you go, 23. What are those two line segments called? Secants. All right, everyone remember, hits the circle in two spots. How do I find the lengths of the secants? I'm going to give you a nice theorem to remember. It's actually, it's not even a theorem. It's a saying I'm going to have you remember. All right, when I'm asking for the lengths of some secants, here's what I'm going to have you remember. This little saying, whole times external equals whole times external. Whole times external equals whole times external. What do I mean by that? Let's use this diagram. Somebody give me the name of a whole secant in that diagram. Give me a name of a whole secant. Nope. No. 20, give me a name of a whole secant. What is it? AD? EDA. Yep, I'm just going to call it AE. Now, what do you think the external word means? The part on the outside. So take secant AE. What's the part on the outside? Name it. 18. Name the part on the outside for secant AE. DA. So AE times DA. Everyone see where that came from. Whole secant times its external part. Do the same thing on the other secant now. Give me the whole secant name on the other one. 9. CA times its external part. 21 external part. AB. There you go. That's for secants and tangents. Secants and tangents. All right. Next diagram. What are these two? What are these two called? Here you go. 22. What are those two? Yeah, and the theorem's not going to change. Okay, the theorem's not going to change. Start with the secant, whole secant. It's 27 whole secant. dB times its external part. 3. CB. Ooh, here we go. Let's go to the tangent now. See what people have to say about the tangent. Again, we're going right from the point of tangent C to the external part, the point on the outside the circle. 4, whole secant. AB. What about its external part? External part there, 7. Also AB. Anytime you're dealing with the tangent, whole and external are going to be the same. So if you wanted to impress your friends later on in the cafeteria, if you do have a lunch, I can really write this as AB squared. All right, so for the tangent, the whole and external always the same. Oh, before we get into problems, there's one combination I didn't do. 2 secants, tangent and a secant. What didn't I do? Do you know why I'm not doing 2 tangents? That's not a tangent. Anybody know why I'm not doing 2 tangents? Ella? Darn right. We have a theorem that says they're congruent every single time. All right, so just remember that little party hat for you. All right, let's do it. Find the value of each variable using chords, secants, and tangents. Okay, that first diagram, 26. This first diagram, what's involved? What are those 2 segments? 2 secants. Because, hey, coming off of Thursday's lesson, here's what I'll get right away. Oh, 5 times 10 equals 4 times x, because you guys are so used to the chords. These are not chords. These are secants. It's a different theorem. Different theorem. Give me a whole secant length now. 23, whole secant length. 15, what is it? 15. How about its external part? 15 and 5. Go over to the other secant. Be careful. What's the whole secant on the other side? 4. 4 plus x times its external part. 19. 4. Give you guys a minute. Go ahead. And notice the directions. It said round to the nearest tenth if necessary. And when you're ready, what do we got? Nearest tenth. When you're ready, 2, what do you end up with? 14.8. No issues yet? Diagram 2. What are you shown in diagram 2? What are those 2 segments? 8. What are those 2 segments in diagram 2? Okay. Secant tangent, whole times external, whole times external. Give me a whole secant length. Here you go. 12. Give me a whole secant length. 11. How about its external part? 2. What about the whole tangent? I'm not talking to you. 27. Y, and then the external part is also y, so that'll be y squared. Yep. So you guys are finding out the square root of 22 to the nearest tenth. Go ahead, 12. What do you have for me? 4.8. Anything on the basics here? Okay, for 3. What are those, first of all? Always ask yourself, what am I working with? 15, what are those? 2 secants, whole times external, whole times external. Give me one whole secant here. 21, give me one whole secant length. 8 plus y. And what about its external part of that one? 8. All right, be careful on that next whole secant. Next whole secant, what do you got for me? 5, what do you have for me? Next whole secant. Nice job. Y plus 10, combine the 7 and the 3. And how about the external part on that one? 7. When you're ready, value of y, 2. Value y, 6. Could we add chords into the diagram? Yes, we can. Look at number 4. It's almost like a big circle, but for lengths now. All right, now you have chords. Everyone see, how many chords are in this diagram? How many chords do you see? I see RP. Are there any other chords? Other than RP, are there any other chords in this diagram? 6, any other chords you see? No, it's not technically. Yes, it is. NM. Yep. You got it. Yep. PR and NM, they're chords. I got a tangent, and I have a secant. And X and Y. I'm going to let you guys know. One of them you can find, one of them you can't find. Let me start with the one you can't find. Who's got 19? Here we go, Maya. You see the tangent, y? So I would do y squared, right? And I would have to pair that with the secant. Now, how long would you say that secant is right here? Because you got different pieces of it, but put them all together, and how long is it? Yeah, and I don't know about you guys, but I'm already done. I'm done already. There's no chance. I'm done. So do you see how y is out of the question right now? Because I have an equation with y and x. All right, could I find x, though? Remember, hey, how many chords did we say there were up here? 2, and they happen to intersect. So let's go back to Thursday's class. If 2 chords intersect, the product of their segments are equal. Name 2 pieces of one of the chords for me that I'm going to multiply. 26? 4 times x. These 2 pieces right here. And then take the other chord. What 2 pieces are they broken up into? 10. Perfect. I should have known that. 28. 3.2 and 10. Everyone see that using Thursday's theorem. The 2 intersecting chords. Now I can find x, and once I find x, we can get on our way and find y. 4x equals 32, x equals, okay, 8. Okay, take 8, plug it back in. Now I'm going to ask somebody, how do I find y now? With a tangent and a secant. 15, ready to set this bad boy up? Okay, whole tangent. Y squared, external part is also y. Here we go. Now that you know that's 8, what's the whole secant length? Okay, 18. And how about its external part? 6. Y squared equals, what's that, $1.44? Good talk. No, that's not 6 times 8. That's not 144. It's not even close. That's an 8. Carry it's 108. Come on, get with it. I feel like I could draw a picture of a chair up here sometimes, and you guys would just let it go and not even stop me. Y squared equals chair, and you'd be like, oh, chair. Yeah, okay, I got that. He knows what he's doing. Nobody say a word. And what are we looking here? 10.4? Okay. Yes? Because it's labeled as y? I don't know. What's that? Right here to here? That's the part that we're talking about in whole and external. Because remember, you can't find an actual length of a full tangent line because it's a line and it goes on forever. So we're actually, if you want to get more specific with the term, we're actually talking about tangent segments. Correct, yeah, just a segment of the tangent. We all good? Everyone got a calc in front of them because some nightmares are about to come back on this one. Ready? Round to the nearest tenth for this one. Boy, you have no idea what's coming and what I'm going to make you honors kids do. All right, 10, we'll start. Oh, no, we're not. How about 20? We'll start off with 20. What's the two things, my two pieces in my diagram now? Secant and a tangent. So I'm going to do whole times external, whole times external. Start anywhere you want. 22, give me a whole segment of either one. Ooh, nice. Going with the tough one. I like it. Respect. 2x plus 4, the whole secant times its external part. Everyone all good? Let's go to the tangent now. Why am I bothering? 10 squared, 100. Okay. 2x squared plus 4x equals 100. We've been down this road a lot of times, I know. 9, what's your next move here? So you want to divide, okay. So you can move the 100 over and then take out the 2. You can take out the 2 now. It doesn't matter when you do it. So I'm going to have x squared plus 2x equals 50. Got it. Next move. 19. So I do have an x squared here. You got it. Let me know when you get those two numbers that multiply to 50 and add to 2. Let me know. Let me know. Still waiting. Anybody finding them? Because you can't. All right. That's why the direction said round to the nearest tenth. Probably wasn't going to be a whole number. All right. So I can't find two numbers that multiply to 50. There's got to be other ways to solve this, though. The quadratic. You think that's bad? Wait, I'm going to have you do it a second way after we're done here. All right. If you think that's bad. All right. So here we go. Here we go. Quadratic formula on the formula sheet. Negative b plus or minus square root b squared minus 4ac all over 2a. I know it's been a couple units since we used this. I just want to remind you how I'm going to ask you to use this. What's your b value, first of all? Is 2. So when I plug it in for the first part, it will be -2 plus or minus. Now, if you remember correctly, I do not want to see any single numbers substituted in here. How should you be getting this b squared minus 4ac value right now? Storing a, b, and c in your calculator right now, and then doing b squared minus 4ac. All right, I don't want to see any numbers substituted in because that's where the mistakes happen in this formula. So everyone go ahead, substitute. Hopefully I don't have to tell you what the a, b, and c values are. Store those in your calculator and figure out what the b squared minus 4ac value is. And when you're ready, what's that number you're getting underneath there, 12? $204. We should all be getting 204 underneath the radical, I hope. All over 2 times, a value is 1, so 2 times 1. Anybody issues with getting 204? Because now we're actually going to find the final answer here. All right, it's plus or minus, so you're going to get 2 answers. You're going to get -2 plus the square root of 204 over 2. And you're going to get -2, where's the second one come from? Minus the square root of 204 over 2. And again, you guys that have fraction templates, plug it all into a fraction template right now, please. And round to the nearest tenth. Plug it all into a fraction template. If for some reason you don't have a fraction template, do the numerator first, find out what that decimal is divided by 2. And we're rounding to the nearest tenth, so take your time, take your time. Whenever you're ready, whenever you're ready, 20, let me know. 6.1 for the plus version, yep, and for the minus version? -8.1. Any discussions right now? Hi, I'm a diagram. Any discussions right now? Again, hello, if you didn't meet me the first time, I'm a diagram. Any discussion on my 2 answers there? Evan? Can't have a negative length up there, right? I cannot not have a negative length, so like some of you fellas in prom time in a couple years, rejected. All right. Come on, we're like on week 35 here. I'm sure you've heard worse. 6.1, everybody good? All right, we're not ready to go to the homework then. I told you there's going to be a second way, and this is not to be painful. It's not to have consequences for you guys. We are going to be doing this tomorrow, all right? There is a second way we could have solved this. You know you can't factor, so that's out. You could use quadratic formula, and I want to review the second way we could have done this, which we're actually going to do in class tomorrow with what we're doing. Anybody remember from last year the second way? Little CTS. Completing the square. Yes, here we go. I don't know where you got room on your paper to do this. I'm just reviewing this now because I'm going to make you do it tomorrow. You have to do it tomorrow to be able to do what we're doing. All right, so start with the original quadratic. X squared plus 2x minus 50 equals 0. Let's complete the square on this one. Just so I can have a good laugh here. Anybody know the first step, completing the square from last year? Go ahead, Evan. There we go. Get your C value to the other side. All right, c value's got to be moved over. So you got x squared plus 2x equals 50. Next. Anything. Anything. All right, you have to come up with a new c value. You have to come up with a new c value that you will add to the left and to the right to keep it balanced. Anybody remember the procedure to find that new c? Let's go, Carolyn. Nice job. Everyone, what's my b value up there? 2. So to find this new c value, I take half the b value. So everyone in your mind right now, take half the b value and square that number. What do I end up with? Half of 2 is 1. Squaring 1, you get 1. Yeah, so here's what I'm going to do. X squared plus 2x plus 1. And to keep it balanced, I do have to add the same to the other side, 1. So I do have 51 on this side. On this side now, I am going to factor this into a perfect square. I'll do the work over here, but do you guys know what that factors into if I did ask you to factor it? 2 numbers that multiply to 1 and add to 2. 1 and 1. So how could I rewrite this as x plus 1 all squared? And there is a trick to get that number there. Anybody remember that one? Anybody remember coming up with this number somewhere? It's always half your b value. Whatever half your b value was, that's the number will go in there. All right, we're really done completing the square. You're done. You've completed the square. Now to have your algebraic tools take over. What do I do on both sides to get rid of the squared? Okay, here we go. Square root both sides. The completing the square is done. You get x plus 1 equals, watch your mouth here. You can say square root of 51, but plus or minus, yeah, that's where those 2 answers come from. Yep, plus or minus. And then you're solving for x, so how do you want to move over the 1? How do you want to move over the 1? Subtract it. So negative 1 plus or minus the square root of 51. And then again, if you guys now do those 2 answers, x equals negative 1 plus square root of 51 and negative 1 minus the square root of 51. You should end up getting both of 6.1 and negative 8.1. And there's the 6.1 and there's the 8.1. Okay. Get the c value over, half your b squared, and then finish it up. All right, as much as you may hate that right now, it's going to be forced tomorrow. We got no choice tomorrow but to complete the square with what we're doing. All right, you guys know what the assignment is. Also, anybody notice there's no review problems this week? I just feel like we got to focus on this circle stuff full time now. All right, so no review problems to worry about. We can work on the circle stuff full time.